In working with propositions, we need to connect different propositions together, and we use different means for this. One is the conjunction, which means and it's denoted by this symbol. So basically, it's just the and, P and Q. So we've got an example here. My P proposition, John studies mathematics. Q, John studies additional mathematics. So this is P and Q. So P, the conjunction, and Q would say that John studies mathematics and John studies additional mathematics. Now, this can be put into what we call a truth table, and for this to work, then both of them have to be true. So we've got all the different possibilities. John could study mathematics, that's true, or it could be false and false, and he could also study additional mathematics, would be true and true, or false and false. But for the conjunction to be true, it has to be true for both. So you can only have one true and all the rest are false, because both of them need to be true. If we represent it on a Venn diagram, it's the intersection between two sets. So here we have the intersection, which is denoted by that symbol over there. So this corresponds to that. It's the intersection between two. It's this shaded area over here would be the conjunction, the and part. Now going into the disjunction, this is the or. Now we have two possibilities here. So the or is denoted by this symbol over here. So when we have two, we have P and Q, P or Q. Now when it's written like this, it can be all or possibly both. So we can have all or both when this is all or both. So in our truth table, it actually works out that this would be true. That's true, true. So, and then the disjunction would be true, true, false, because it's one, true, false, or false, true. So these two. But here when we have false, false, that would be false, because it has to be one or the other or both. Now, it can be related to us in our Venn diagram by here, where we have P and Q, and we can see that the shaded region here is all of this, because it can be both. So it can be P, it can be P, it can be Q, or it can be both, this area over here. So all of that is our P disjunction Q. With the exclusive disjunction, this can be or, but not both. And the way that we denote it is like that. So if we have two, we have P, the exclusive disjunction, and Q. We can have that P can be true or false, and Q can be true and false. But for this to be true, either one of these must be true, but they can't be both true. So if we look at the truth table for this, true and true, that's false. But both of these, you have one of them is false. So it's the or, one or the other, but not both. So this would be true, this would be true, but false, false, obviously that is false. So this is the truth table for this. Now, if we represent this on a Venn diagram, if this is my universal set and this is P and Q, then we have these two. So it can either be this part over here, the P can be, or it can be the Q, that part, but it can't be this. It can't be the intersection, because that would mean that both would be true. So that's how we represent it on a Venn diagram.